Assalamualaikum and hello everyone. My name is Muhammad ZUHAIRY bin RAZALY from DDT2B. I'm the main video editor for this video. I will explain to you on how to find minimal spanning tree for these two maps, which is Tokyo map or also Seoul map.
Assalamualaikum and hi everyone. My name is Muhammad NAIM bin ISMAIL from class DDT2B. And my matrix number is 01DDT20F1039. So for my part, I will explain the introduction of minimal spanning tree, technique apply which Kruskal algorithm and Prim's algorithm, and I'm also will explain about Bangkok map and Perlis map.
Hello, my name is Muhammad IZZAT SULHI, and my metric number is 01DDT20F1038, and I'm from DDT2B.
Introduction of spanning tree. A spanning tree is a subgraph of an undirected connected graph, which includes all the vertices of the graph with minimum possible number of edges. If a vertex is missed, then it is not a spanning tree. A minimum spanning tree is a spanning tree in which the sum of the weight of the edges is a minimum as minimum as possible. Next, I will explain the technique that apply for minimal spanning tree. First technique is by Kruskal algorithm. For Kruskal algorithm, need to find the edge in the graph which smallest weight. If there is more than one, pick one at random. Mark it with any color. Step 2, find the next edge in the graph which smallest weight that doesn't close a cycle, and then color the edge and the next incident vertex. Step 3, if G has a vertices, stop after edges have been chosen, otherwise repeatedly. And for Kruskal and next is for Prim's algorithm. For Prim's algorithm, need to select any vertex and choose the edge the smallest weight from G. Step 2, at each stage, choose the edge of smallest joining a vertex already included to vertex not yet included. Step 3, the last step, continue until all vertices are included into the graph.
Okay, now for the first one is the welcome to Tokyo map. Okay, for this welcome to Tokyo map, we use Prim algorithm in order to find the minimal spanning tree. For Prim algorithm, we will choose the edges that have the smallest weight. In this map, the smallest edges that have the smallest weight is Abiko to Moria, which is 1.0 km. So we will highlight with red color first, Moria to Abiko, 1.0 km. And then after that, Abiko to Habashi and also Moria to Tachikawa. Okay, between Abiko to Habashi and Moria to Tachikawa, Moria and Tachikawa have a smaller weight which is 1.3 km than Abiko to Habashi. So Moria to Tachikawa. Okay, after Moria to Tachikawa, we will choose either Tachikawa to Yokohama or Abiko to Habashi. But if you see, Abiko to Habashi have a smaller weight than Tachikawa to Yokohama, so Abiko to Habashi. And then Habashi to Nerima, because it is the smallest weight between all of them, which is 1.2 km. So we will do Habashi to Nerima. Okay, next Nerima to Mitaka, because it have the same weight with 1.20 km. Okay, now after that Mitaka will either go to Yamato or either Nerima go to Noda, but we will choose Nerima to Noda because it is smaller than Mitaka to Yamato. So we will choose Nerima to Noda. Okay, after that we will choose either Noda to Yamato or Noda to Haruma or Noda to Yokohama, but Noda to Haruma is the smallest between them, so Noda to Haruma. Okay, next is Haruma to Yokohama. Because Haruma to Yokohama, it is smaller than Noda to Yamato. We will not do Yokohama to Tachikawa because it will perform a loop inside the tree. So Noda to Yamato, which is 3.3 km. So this is the minimal spanning tree that we found in this Welcome to Tokyo map. Okay, next, this is the minimal spanning tree that we draw based on the Welcome to Tokyo map. As we said, Abiko to Moriya is 1.0 km, and then Moriya to Tachikawa 1.3, Abiko to Habashi 2.4, Habashi to Nerima 1.2, and Nerima to Mitaka 1.2, Nerima to Noda 2.3, Noda to Haruma 2.0, Haruma to Yokohama 2.3, and Noda to Yamato 3.3. We sum all of them and we will get 17 km. So this is the answer for this minimal spanning tree, which is 17 km. Okay, now for the second one is Welcome to Seoul map. Okay, for this Seoul map, we will use Kruskal algorithm in order to find the minimal spanning tree. Okay, for Kruskal algorithm, we will choose two edges that have the smallest weight among all edges. Okay, in this map, we find that Buchon to Guri and also Anyang to Songnam is the smallest among all of them. So we will choose these two first as our starting point. Okay, the first one we will get Buchon to Guri because it is smaller than Anyang to Songnam, 0.5 km. So Buchon to Guri. Okay, after Buchon to Guri, we will choose Anyang to Songnam, which is 0.9 km. Okay, after Anyang to Songnam, we will choose Songnam to Gamyong because Songnam to Guri is 1.2, but Songnam to Gamyong is 1.0, which is smaller than Songnam to Guri. Okay, so we will choose Songnam to Gamyong. Okay, after Songnam to Gamyong, we will choose Songnam to Guri and also Guri to Sihung because Songnam to Guri is 1.2 and Guri to Sihung 1.2, which is same, and both are the smallest among all of edges. So Guri to Sihung. Okay, now next is Incheon to Gonyang because Incheon to Gonyang is the smallest among all of them. So Incheon to Gonyang 1.4 km. We will choose that. So Incheon to Gonyang. Okay, after Incheon to Gonyang, we will choose Guri to Hanam 1.5 km because it is smaller than Anyang to Incheon 1.8, and also it is smaller than Hanam to Namyangju. So we will choose Guri to Hanam first, 1.5 km, and then between Hanam to Namyangju and Anyang to Incheon, we will choose Anyang to Incheon because it is smaller, 1.8 km. So Anyang to Incheon. And lastly, we will choose the remaining vertices Namyangju, so Hanam to Namyangju. Okay, this is the solution for the minimal spanning tree inside this map. Okay, now this is the minimal spanning tree that we draw based on the Welcome to Seoul map. Okay, we use the Kruskal algorithm to find the minimal spanning tree. Okay, as usual, first is Guri to Buchon 0.5, Songnam to Anyang 0.9, Songnam to Gamyong 1.0, Songnam to Guri 1.2, Guri to Sihung 1.2, Buchon to Gonyang 1.4, Guri to Hanam 1.5, Anyang to Incheon 1.8, and last Hanam to Namyangju 2.0 km. We sum all of that and we will get for 11.5 km. So 11.5 km is the answer for the minimal spanning tree inside this Welcome to Seoul map.
Okay, so for my part, I will explain for Bangkok map to find the minimal spanning tree by using Kruskal algorithm. So first step is we need to find the smallest edges, which the smallest distance. So first one, I will choose from Pattaya to Siam Square. which distance is 0.5 kilometers. Then I will highlight the route from Pattaya to Siam Square. Okay, next we go to second smallest edges, and which the smallest distance is Chitlada, from Chitlada Palace to Democracy Monument, which 0.9 kilometers. So I will highlight the route. After that, I will choose from Democracy Monument to National Assembly Hall, which distance 1.0 kilometers. Okay, highlight which the colors, and then I will select from Payatai to Victory Monument, which 1.0 kilometer for the distance. Okay, and then I will pick from Democracy Monument to Chinatown, which is it have smallest distance, 1.1 kilometers, and I will highlight the route. Okay, next, from Chitlada Palace to Payatai, which 1.2 kilometers. After that, from Democracy Monument to National Museum, which the distance 1.2 kilometers, and the route will be highlighted. Next, I will select from Chinatown to Memorial Bridge, which 1.9 kilometers distance for the route, and will be highlighted the route. And then for the last one is from Siam Square to Lumpini Park, which distance 2.0 kilometers. Why I said is last one, because the other edges I cannot to choose to pick, because the other edges will form a cycle and loop. So we will get, so right here we get the obtain the diagram for Bangkok map. So for the calculation, I already make a table which include the routes and the distance for every route, and to get the total minimal spanning tree, we need to plus all the distance for from every route to get the total for minimal spanning tree. So I will plus all together from 0.5 plus 0.9 plus 1.0 plus 1.0 plus 1.1 plus 1.2 plus 1.2 plus 1.9 and plus 2.0, and we will get the total answer. Total minimal spanning tree is 10.8 kilometers distance for Bangkok map by using a Kruskal algorithm.
Okay, for the fourth map, it is welcome to Melbourne. for this map, we using a prime algorithm. Okay, firstly, we must choose the smallest edge, and for the first, the smallest edge, it is Olympic Park to Yarrow Park. Because it is the smallest edge, it is 1.0 kilometers. And then second, it is Olympic Park to city center, because it is the smallest edge, and for the distance, it is 1.2 kilometers. Okay, third, between Yarrow Park to Royal Botanical Gardens and City Centre to Flagstaff Gardens, we choose Yarrow Park to Royal Botanical Garden. It is 1.4 kilometers. And then fourth, we choose City Centre to Flagstaff Garden, because it is a smallest edge and it is 1.5 kilometers. And then between Flagstaff Gardens to King's Domains and King's Domain to Royal Exhibition Building, we choose Royal King's Domain to Royal Exhibition Building, because it is the smallest edge and the edge is 1.6 kilometers. And then we choose a Royal Exhibition Building to Fitzroy Gardens. It is 1.7 kilometers. And then a smallest edge is Flagstaff Gardens to King's Domain, because it is 1.8 kilometers and it is smallest edge now. And then next, the smallest edge is Royal Exhibition Building to Melbourne Museum. It is 2.2 kilometers. And then the same distance, it is Melbourne Museum to Government Heights. It is 2.2 kilometers too. Okay, it is all. That's all.
Okay, for the calculation, we want to know about total minimal spanning tree and how to calculate it. To calculate the total, we just plus the minimal spanning tree. Okay, first 1.0 plus 1.2 plus 1.4 plus 1.5 plus 1.6 plus 1.7 plus 1.8 plus 2.2 plus 2.2, and then plus 8, and the total is 14.6 kilometers. Okay, it's about the calculation.
So for the last map, Perlis map, I will explain the Perlis map, and by using a prim algorithm to find the shortest way and the total of minimal spanning tree for Perlis map. So what we got here is we need to find, first one, we need to find the shortest distance or weight, and I will choose, and I will start it from Perlis State Park. Okay, so I will choose Perlis State Park first to Royal Gallery. Okay, and then which 1.0 kilometers, the smallest distance, and I will highlight the route to make it different. Okay, next I will select from Royal Gallery in to city center, which 1.2 kilometers for the distance, and we'll highlight the routes. Okay, after that I will select from Perlis State Park to Timah Tasuh Lake, okay, which distance is 1.4 kilometers for the route, and will be I will highlight the route. Okay, and then we go to I will choose city center. From city center to Harum Manis Stall, which a distance just 2.4 kilometers, and the route I will highlight the route to make it different. Okay, after that I will choose from city center. I will pick from city center to Homestay Raya Guring, which distance 3.0 kilometer, and will highlight the route. Next, I will select from Homestay Paya Guring to Kuala Sanglang, which the distance is 4.3 kilometers for the distance. And then from Kuala Sanglang go to Sugar Cane Plantation, which the distance is 3.7 kilometers, and will be highlight the route. And okay, and then we go from I will pick from I will select from the last one I will select from Sugarcane Plantation to Padang Sar, which the distance is 2.6 kilometer. Why I said this is the last edges that I will choose? Because the other edges, if we choose, will if we choose, will form a loop and cycle. Because in Prim's algorithm do not allow that happen for the graph. So after that, I'll already get the obtain the diagram after select the root and the edges from the smallest one. So this is the diagram and the calculation, and I make the table for the calculation, and on this table contain all the route that I already been choose before this, and the distance of every route. So to get the total minimal spanning tree, we need to plus all the distance from the first until the number 9. So we will plus all the distance, from 1.0 plus 1.2 plus 1.4 plus 1.5 plus 2.4 plus 3.0 plus 4.3 plus 3.7 plus 2.6, and we'll get the distance for the minimal spanning tree is 21.1 kilometers for the distance of Perlis map by using Prim algorithms method. So that's all from me. Thank you.
Okay, for the conclusion is the important on minimal spanning tree. Okay, minimal spanning tree are useful as they find a lot of tasks such as finding a minimum connected path across various components in very large-scale integration (VLSI), several network and design routing problems. Minimal spanning tree aids in approximating solution to the traveling salesman problems. Then, the consequently is the problem has attracted much attention of researchers and several algorithms have been proposed for it. Okay, just for that, for the conclusion.
Okay, that's all about this case study.
Thank you.